Good afternoon, everyone. I think we'll make a start so that we can have a really useful discussion this afternoon. Hope you had really productive sessions this morning and enjoyed your lunch and ready for a stimulating discussion about restoration trajectories. I'm Emily Dresner. I'm the project manager for the England Peatland Restoration Roadmap, Map in England, and I'm chairing this session this afternoon. We've got a great range of speakers to talk to us about the research that the peatland community is doing about how recovery is happening, what that looks like. So we're looking to have a really good discussion this afternoon, a knowledge exchange, and really drawing together the different work being done to evidence recovery. Identifying gaps and opportunities, and what can we do to support this work. So before we welcome our speakers to the stage, I'll just say a little bit about how Natural England, IUCN and National Trust in particular thought we could bring together this discussion to help support some of the work that's going on nationally. So the Peatland Restoration Roadmap, which I'm leading on, has been developing for about a year now. And we just recently convened the Technical Advisory Group, which is bringing together practitioners and research academics to draw together that experience about what evidence can underpin our trajectory to recovery. And that work can really be informed by the knowledge that's out there in the community. So we thought this discussion would really help bring that together. The first speakers we'd like to invite to the stage are Emma and Brian from DARA. If you look on your app, there is a list of the speakers in the running order. But if you're not having access to that, then Emma and Brian are going to be talking about flux tags. Thank you.
Hello. Good afternoon. My name is There you go. My name is Emma Reeve, so I am the Peatland Link Officer within the Northern Ireland Environment Agency. Part of my role is to identify the science and evidence gaps within the peatland restoration, management and conservation work, to help shape the criteria for our environment fund, and then to act as client officer for some of those projects that we have bids in for. Just to start, we really need to understand, like everybody, I made a conversation this morning about the England Peat Map project. So, in Northern Ireland, just to understand the challenge which we face with peatland restoration, we have the 2017 report, which indicated that Northern Ireland constitutes 242,000 hectares, approximately 8% of the UK peatlands, contributing to about 10% of the greenhouse gas emissions. That was based on the best available maps at that time and the emission factors at that time as well. Ongoing mapping work undertaken by the James Hutton Institute, which has been funded by ourselves and has been and coordinated by Ulster Wildlife, would indicate that we have approximately 310,000, so it's about a 20% increase. And that's using the DEFRA, the current 2023 DEFRA emission factors. And it's really important that we understand this because we have a challenge set to us by the Climate Change Committee of 150,000 hectares to be restored. So when that map gets verified and peer-reviewed and published, taking into account the new EFs, maybe there's potentially a change to that figure, or perhaps hopefully doesn't increase by much anyway, because the challenge is rather huge in Northern Ireland at the moment. So that's just setting the scene for that. And as I said, they were based on the 2023 DEFRA emission factors, but through that project as well, what has actually been simulated is a conversation with regards to the application of the peatland condition categories to Northern Ireland's peatlands. You know, it's a UK-based category, and does it work across all of the devolved administrations, and similarly about the emission factors that are being used. So, pardon me. Part of my role then was to, as I say, identify the science and evidence gaps. So what we have in Northern Ireland is the Environment Fund, and we have a number of strands, and one of those is called the Challenge Fund strand. So based on the fact that this was indicated as an evidence gap, we reached out to CEH in about 2019, maybe even early 2020, and then obviously it took its time, but we now have 4 towers that is installed in Northern Ireland, which are really there to sharpen the people and emission factors post-restoration on now these 4 sites. So we have 4 flux towers at present. They are based on categorised from condition worst to best, and my apologies, whenever I was writing this or putting this up, I didn't actually put pictures of the bogs, which would have been really useful whenever you go to see, whenever I'm talking about the results from the tower report, but there we go. So Glenullen, let's just say it had been wrecked. It had been drained for commercial extraction and then had been burnt. Thankfully, no extraction took place on it. The next 2 sites are SICs, and they're designated because of their existing favourable condition, and they have undergone significant restoration works. And then we have the Glenmurray Hill Farm, which has undergone some restoration works with, prior to the flux tower being installed, ambitions to re-wet the Muir in its entirety. Because of that now, we are integrated obviously with the CEH and Amflux network, and also because of that, we're now part of the Mothership project, which is really beneficial given that these are obviously, when our flux towers are installed, they're installed at point sources, and obviously things like water table depth are obviously only just recorded at that one particular area. And next, okay. Again, just to say, I'm the client officer for this. I am not a flux scientist, and if there's any tricky questions on any of this data, I will certainly bring that back to CEH and find out for you. But I'm here to present in the sense I work, and I've definitely better understanding within myself, but within the department as well, which has been really beneficial in understanding then our returns to the inventory in itself. So let me just get this all correct. So all of the sites exhibited similar patterns with regards to the soil temperature and air temperature trends. Unsurprisingly, the total precipitation was highest at our highest elevated site, which is the Glenmurray Hill Farm, and the lowest at Gary Bog. And then the figures from the figure 4 from here, so this is from the report, Gary Bog, and this is where it's important to remember the Mothership connection then. Gary Bog has indicated the shallowest water table depth, and then at Glenmurray the lowest water table depth. If we can get the definitions there on that, correct. The evapotranspiration, so Glenullen, it was observed to have the highest evapotranspiration rates, and Glenmurray the lowest. And again, this is unsurprising given that Glenullen was the site that had been completely trashed, has undergone significant restoration works, and there's significant pooling in the block drains at this present moment in time. And then Glenmurray, where it's an open moorland, there's graminoid dominant vegetation, and it's got higher rates of photosynthesis there, and then also there's potential high or low hydraulic conductivity at the site. So the methane, the net ecosystem exchange. So this indicated actually that Glenmurray was there were 3 of the sites, and it doesn't help that they're called Glenmurray, Glenullen, Gary, but Glenullen, Gary and Ballinahone are all actually considered to be CO2 sinks at this point on CO2. That Glenmurray sequestered 372 CO2 grams, carbon dioxide grams, and Glenullen, however, it admitted, so it's a slight source. Again, unsurprising given the recent restoration activities that have taken place on site. But when we looked at when the methane measurements that were recorded, all sites emitted between 3 and 6 grams of the methane over the study period, with Glenullen emitting the most. That was considered surprising given the link between methane emissions and water table depth. But when we come back to it and say the Mothership project will help us understand that a bit more, because the Gary Bog is the lowest at that single point. It's not across the entirety of the bog. So there's benefits as Gary being a golden site as well as Glenmurray being a golden site. We get a lot more data which will help explain these results and these trends. And then with the methane at Glenullen, this beauty of having the long-term measurements are actually stressing the importance of the long-term measurements. This should hopefully indicate that this is an immediate short-term pulse in the methane following significant restoration works. So yeah, whenever they're switched into CO2 equivalent, it actually turns out that Glenmurray is our only site that would be considered technically a sink, and that the other 3 sites, even though Glenullen was already considered to be a source, that the other 2 sites are actually sources of CO2 equivalent. So it's an ongoing project. These are only in the past couple of years. The past couple of years we have not had our typical weather patterns, so it's just reinforcing again the necessity to have long-term measurements in place. We've had a few issues with it. The issue is not the dependence on CEH technical expertise. The issue is that CEH are not based in Northern Ireland. They have been fantastic in giving us support remotely, and we are anticipating a visit from them next week to do some more of our exceptional maintenance works. We've had a few issues with stability and operation of the equipment. My thanks goes to all the field officers within Ulster Wildlife and within NIEA who actually go out and do this work on top of their own daily business as usual work. Some of them love an excuse to go out in the bog. They're stuck at their desks. However, mid-January they're not so keen, still have to go. And then actually that staff resource itself, it's a civil service, there's a lot of movement, a lot of temporary promotions, and sometimes it's actually difficult to retain those trained up staff to go out there who have the confidence to go out and do the routine maintenance, but sometimes this sort of exceptional maintenance. And our next steps for this is, we need to continue measuring at these flux towers, addressing any issues quickly that turn up. We really need to expand this Northern Ireland network, and there's ongoing discussions with that so that we get a best representation for our peatland condition categories. And really importantly as well is that we need to develop this Northern Ireland technical base and competencies for undertaking this monitoring. And that again is a work in progress. So all of this is just really important so that we understand the drivers for peatland restoration, we understand the greenhouse gas emission impacts post-restoration so that we know that what we're doing is the right piece of work to be on. So we'll pass on to Brian.
Okay folks, I'm just going to give you a quick chat about the site where one of the flux towers is at Glenwerry, and tell you what we're doing really with Emer and Ross's tower. So first of all, Caffrey is, we're really a bunch of farmers, so we'll be talking in tons per hectare rather than grams. What we do is we've got our students, 1,600 students, 3,000 business development group members from farmers, and then we also bring in department policy and show them, try and translate research into on the ground activities. And the yellow star shows where our location is. So this flux tower data, there's a Cosmos CEH weather station further down the hill. It's sitting at about 150 metres above sea level. The blanket bog flux tower sitting at 300 metres. Quite amazing the difference in rainfall over the last 4 months. There's an extra 70 mil of rainfall out of 400 when you just go up another 150 metres. And that's not even counting fog and mist that Richard was telling me about last night. So we get lots of data through there. Okay, I'll get daily data. Okay. To give you an idea about the site, there's lots of monitoring going on at the site. So the green mark on the right-hand field, that's where the flux tower is. Then there's light blues, a lot of dip wells about, a lot of vegetation assessments, and then there's also 3 flume locations. So the large field on your right, that's about 160 hectares. So that's a nice moor agriculturally. So we've been grazing sheep on it for the last 25 years. We would have had cattle grazing on it beforehand. It's a fairly dry moor. So there's a drain about every 60 metres, and then there's a lot of peat pipes, sort of southwest facing. So there's quite a lot of peat pipes in it as well. So I would be anticipating that would fall into the category, of drained peatland, and would be emitting, 1 or 2 tonnes per hectare. So that was the starting point. We promised not to do anything more whenever Ross put up the tower for a wee while. We're also looking at the whole picture. So I suppose because we're farming, we're starting off with farming livestock, then we've moved into biodiversity, and now we're adding on carbon, water quality, etc. So we're trying to farm all these bits. So our fluvial carbon story would have we've been taking data for the last 3 years. You can see 2 bottles there. One's from the open moor and one's from the forest, and now converted to forest to bog. So we were getting very low levels, about 0.2 tonne a hectare of CO2 equivalent from the open moor, and that was our anticipation. Then we put in some, Ulster University are working with us, so we put in some flumes for them, fully automated flumes that started in March 23, and I just got the data a couple of days ago, so I don't have a graph for you, so I just have to do an air graph. So if you can think of cumulative TOC up the side, and down below we're on dates, so March to August. So the stuff tickled along nice and gently, giving us a predicted output of about 0.05 tonne of carbon per hectare. And then we had a dry spell of 31 days in a row, which is not like us at all. And we got that in mid-May through to mid-June. And then since mid-June we've been in monsoon time, which is more normal. So basically the DOC ticking along like that, end of the dry period, rain came, whoa, straight up, and it hasn't come down or changed angle yet. So that means we're probably looking at about 0.8 to 1 tonne of TOC losses per hectare this year. So that was a bit of a surprise. This is also a catchment for Killeen Reservoir, serves 60,000 people. We also measure everything else, so we're biodiversity, we're farming biodiversity. Don't have time to talk about that today, just the graphs are all shooting up there, and that's without us changing agricultural output. Our agricultural output's actually increasing. Okay, so the plan before the flux tower came, another site, just half a mile over, we have taken some very poor moor that's drained every 10 to 15 metres. And we've sold about 7 kilometres of drains in there in a 12 hectare area. We've thrown in 700 interventions, and we've raised the water table up there, so very successfully. And water table up, instantly, and sitting there at an average 10 centimetres all the time, never drops below 18 or 19 centimetres. So that's the plan for the other moor, to block the drains that are there every 60 metres. The second thing that we've done is we've done one pilot back in 2021, and we looked at one of the peat pipes. Very easy to find out where it was, because it obviously ends up in a flush, so we just walk up the hill and tell the digger driver. So a second bucket full, we found the pipe. And basically we broke the pipe, made a series of dams, and basically brought the water up and then let it release over the dams and through pipes within the dams, all the way down. So that's incredibly effective. So the water table is bang up there all the time. You've moved from about 10% sphagnum in that area to about 50% sphagnum in a couple of years. Just that within about 50 metres to the side of that pipe and drain. So the anticipation was to do that for the whole site as well. So then Emer and Ross's tower is now telling us that we are our net ecosystem exchange in terms CO2 is 3.7 tonne, so minus 3.7 tonne being sequestered in the last year. Methane is about 1 tonne losses in over a 100-year period, 3 tonne over a 20-year period. Then we add in our TOC, 0.8 to 1 tonne, and then we end up with a balance. So at the minute the balance is we're sequestering about 1.8 tonne per hectare. That's in the 100-year time frame. If we did it on the 20-year time frame, we'd be down at 0.1 emissions. So we're now scratching our head, because where do we go next? We're achieving that 3.7 CO2. This is on a moor that is a lot of cotton grass, a lot of descantia, 30% sphagnum, and obviously the flux tower is averaging everything. And in actual fact, the minute you start walking about, you find lots of different other wee bits. I suppose I should be, after Hans's talk this morning, if some of you read it, I should be ignoring the methane now, but I'm not sure of that. So our next steps, well, when you're not sure what to do, you basically do nothing, but you keep on measuring. So we'll keep on measuring and see where this goes for a couple of years. Now that we've got the better fluvial data, be interesting to see what if that was a totally unique dry spell and that sort of thing happened, or if it's going to be a regular thing for us. With 2 PhDs starting, they'll be using portable gas monitors to go and look at specific ecotopes. So we'll go and look at 10% sphagnum, 30%, 50% sphagnum, and see if we can break it down a wee bit closer to what exactly we're trying to tell our farmers to aim for. Chatting to Fernando Fernandez from south of Ireland, we're thinking that probably 30%, 40% sphagnum is the target for blanket bog. The long-term plan is probably to go with the drain blocking and the pipe intervention, but I think we need to collect lots more data before we do that, and maybe do it before, during and after. Maybe we'll split the moor in half and do one half and the other. Sorry. Here to there. Okay, so just to conclude, the sort of things we were doing on the flux tower site, we are measuring all our hill farm outputs. We now, as well as livestock, we look at all these other ecosystem services as our outputs. And those are the environmental measurements on the right that we're doing. So taking a lot of measurements to try and prove these ecosystem services to farmers, unions and policy folks who visit us. That's me. Thank you very much.
Hello, folks. So I'm going to be talking about biodiversity response, widening the concept of biodiversity, and also questioning restoration. That's at the end. So, when we think about restoration of blanket bog, blanket my landscape, what do we tend to think about first as indicators? Well, it's vegetation, time and time again. But if we look at the standard way of describing vegetation, even within a blanket mire landscape, these are the fenland NVC communities that are relevant to the uplands. How often do we find these NVC communities, all of these flushes, spring fens and so on, how often do we find these within the planned proposal for restoration of blanket mire landscapes? We tend to focus on the bog communities, and yet these are an integral part and a really essential part of the biodiversity. So, and then if we go into fens, then we've got lowland fens, we've got 28 swamp and tall herb fen communities to add to that. And essentially what these extra fen communities within the blanket mire landscape highlight is that actually we're not just talking about biodiversity in terms of species. We should be talking about terms of biodiversity in terms of ecosystem diversity, because a blanket mire system is not just blanket bog. It's a whole complex of bog and fen all assembled into this landscape. So it's really important that we start to think about biodiversity in these broader terms rather than just individual species. And although we're outside the EU now, certain principles of the Habitats Directive are really useful in terms of helping us to define, describe, monitor, and set targets for biodiversity. So, favourable conservation status, part of the criteria for that is that all the structure and function necessary for the long-term maintenance of the interest is in place and likely to remain in place for the foreseeable future. Structure and function. It's not talking about species directly. It's also talking about time. We'll come back to that. So, structure and function. This photo thanks to Ian Dyack of Colligar Bog. And what it really does is highlight the structure of the bog surface, not just in terms of individual hummocks, but the fact that we've got a pattern of pools across that site. Structure and function, not species. But then if we damage that bog, if we burn it, then we end up with different structures. We end up with different patterns. We end up with dense tussocks, not soft hummocks. And even, this is glass and moss, one of the first jobs I ever had with Nature Conservancy Council back in 1976 was to survey glass and moss after a massive fire. 95% of the reserve was burnt. So when I go back today, I can still see the evidence of that because of the structure of the microtopography. Tussocks are still very evident. So I'm using structure and function rather than the species as an indication to me that this site still hasn't recovered. We don't use structure and function within the standard evaluation nature conservation systems. So I've devised a condition matrix which takes from top to bottom the different levels or the nanotope structures, the hummocks, low ridge, high ridge, hollow, and so on, and associated with those a typical range of vegetation groups that you find according to condition. So the orange is bad condition, the green is good condition. This sheet, this condition matrix, is designed to be used very quickly across a site. And then if you repeat that, then what you're hoping to see is these groups moving steadily into the green. This is, by and large, structure and function, not vegetation, certainly not species as such. Of course, the other thing, if you burn your bog, is that it goes hard. Nice, undamaged bog is soft. Once you've burnt it, it can be rock hard. Softness is a basic characteristic of bog systems, and we don't measure it. So I devised a penetrometer to work specifically on peatlands. We've been using this. This is us using it in Moor House just 3 or 4 weeks ago. And we've also used it across the demonstrator sites in the greenhouse gas reduction project that I'm working with Chris Evans. And these are the results that we're getting. We are getting difference between sites. What we have here are an agriculturalised peat. We have 2 sites that are fairly damaged blanket bog, and then we have a recovering blanket bog. It's actually, the recovering blanket bog is actually the flux tower site from Moor House. I'm not going to go through which one they are, but you can probably guess which one relates to which condition. Softness tells us something about condition and trajectory. If you're looking at fens in the lowlands, then structure and function is still relevant. For a start, in terms of condition or structure and function for the hydrology, we're looking at catchments. So the slopes around this fen, these are really important for the structure and function of the system. If we don't have control of what flows off these, then we can't guarantee what will happen with this site. Similarly, we can see we have this succession gradient from open water to actually in the corner there, a bit of fen car. These all have completely different structures. And this is really important, for example, for the invertebrate populations. I was in Antwerp a couple of weeks ago at the big Care Peak conference, and I attended a talk by a guy who'd been doing survey work of invertebrates on fens, and he was showing how spiders responded. And I asked, well, did you measure the structure of the fen vegetation? And he said, no. But I can see that might be really useful. We need to keep thinking about structure. And in terms of influencing structure in our lowland fens, well, the auroch was a wetland species. It probably had a quite significant impact on fen structure, and certainly, cattle grazing today on fens, mowing on fens, these all influence structure. Structure, as I've said, is also important for invertebrate species, and as an indicator of trajectory, extinction is a pretty strong signal. Once you've lost a species such as the large copper, that tells you that something pretty serious is happening to your site. But equally, if you can bring the large copper back, that is a good sign that you're achieving what's needed. In bogs, if I'm doing survey work and I hear a dunlin, I will go towards that dunlin because I'm pretty confident I will find a good quality bog. For me, a dunlin is a really good biological indicator. So equally, it's a good target species to have for your blanket mire restoration. Fens, Cranes are great. They're coming back into the fens now in a big way. These are useful indicators, but they're also iconic. So they're really useful for getting the message across. And then, if you want the ultimate ecosystem engineer, you want beavers. If we look at structure and function of this raised bog, Heathwaite Moss in Cumbria, there's a lot wrong with the structure and function of this site. We can see there's just a remnant area of bog in the middle, and all the rest is domestic peat cut. And the river system alongside has been canalised. You get beavers back into this valley. The whole thing could be transformed. And I will continue to bang on to Natural Resources Wales that having beavers in the Typhy Valley along Cwsgotlan Typhy would be a fantastic and really cost-effective way of restoring Cwsgotlan. But if you're dealing with fens, you've got an additional problem. Bogs are convenient because they're climax habitats, but fens, they go through succession. You can't really stop it unless you intervene. So you have to make a choice. Where do I want my fenland succession to end? What is the interest that I'm trying to maintain? So that's an added pressure to those who are trying to manage fenland systems. Favourable conservation status is also very useful in taking a more strategic view to what we're looking at in terms of restoration targets, restoration trajectories. Because it also says, and this is often forgotten, that the natural range of the interest should be stable or increasing. Not the present range, the natural range. So, let's just look at what this means for raised bogs in Britain. This is the present distribution of raised bogs in Britain. Is it the natural range? Absolutely not. Those of us who went to Home Fen yesterday will have been standing on a remnant raised bog that was described as the southernmost raised bog in Britain. Well, yeah, it is, but it didn't used to be. There is remnant raised bog peat all the way down on Romney Marsh on the south coast. So this is closer to the natural range of raised bogs in Britain. Does that mean we should be looking at restoring raised bogs in Surrey? It's an interesting thought. And yes, although Home Fen is currently designated as a woodland, we do seriously have hopes of bringing back that raised bog environment, even down in Cambridgeshire. So, maybe Surrey isn't so mad in the long term. And then when we come to fens, well, they used to dominate all the river valleys along the south coast. What opportunities are there? So I mentioned time. Well, of course, peatlands store their own time capsule. Peat cores allow us to see what they were in the past. They allow us to see the vegetation range that existed, and although we can't use it as an absolute guide to what we should be restoring, they're a very good indication. But we can't restore this. Once you've destroyed the peat, it's gone. Once you've destroyed the past record that's in this peat, it's gone forever. So when we talk about restoration, is it restoration? There are things we can't restore. In effect, restoration, what we do with our sites is actually more like in a trauma room, where what the doctors are trying to do is to halt the worst of the harms. If you ask a doctor what helps a patient to recover, they'll say, well, the patient's body helps it to recover. All I did was remove the harm. So actually, what we should be talking about is removing harm, and then, as with a human patient, there needs to be a period of convalescence. And we almost never think about convalescence for our sites. So, of course, during convalescence, a patient might go through crises, might actually seem worse for a while, despite all the best efforts of the doctor, but that's the body repairing itself. And so when we're measuring restoration impacts, we may be measuring that period of crisis, not the long-term recovery process. Whereas, here's a woodland. It's not really a woodland, it's just a load of saplings planted in a load of grass. But this is going to be a woodland. And if you were responsible for this project, you would not be expecting your funders to demand of you that you prove that this is a woodland in 5 years' time. Your funders would understand that in order to achieve this, you are talking about 100 years plus. Why do we not apply the same timescales to peatland recovery? And I'm sorry for undermining the whole basis of this conference. I would argue we don't restore, we help recovery. We put sites on the path to recovery. And then we allow them to have time, as we would for a woodland. Thank you.
Very much like that, recovery rather than restoration idea. So my name's Peter Benno. I'm a research fellow down at Exeter University. I'm sort of the lead postdoc working with South West Peatland Partnership, but it's very much a collaborative effort between myself and my co-postdoc name and I'm going to be talking about sort of some of the monitoring work we've been doing, particularly just on Dartmoor, and looking at eco-hydrological trajectories of change, I sort of was asked for a hydrology focus, and I'm not happy being a total bog, so I've gone for more of an eco-hydrological sort of change there. So I'm just going to give a bit of a very, very brief introduction to our work. So I'm aware that we haven't been here for a while as a research group, so I'm very sorry about that. But then, let's sort of talk about some of the monitoring we've done on blanket bulb restoration on Dartmoor, but then also just touch on sort of work we've been doing to come up with a sort of space and time substitution, just to get into that longer term monitoring of change following restoration. Just because, again, like we're very limited by sort of short-term funding streams, so we're trying to overcome that. So obviously Exeter University, we're based in South West. We've for over a decade now been very lucky to work closely with South West Baltimore and team at South West Peak Partnership. So that's when we started off working on Exmoor and very, very shallow peak. They're looking at changes there. And we've got another shallow peak site on Bodmin, and there we've got a really cool experiment. Just mostly that's looking at greenhouse gas fluxes from different vegetation stuff. But on Dartmoor and Blanket Bulb, we've got 2 sites. We've got Hanging Stone Hill, which we can very briefly touch on. But then, Flatall Pan, which is where we've done a lot of work. So starting back in 2012, we first started doing some research there. And that site, for those who don't know Dartmoor, it's very much up in the high moor, about an hour's walk in, which is excellent for collecting water samples and carrying out greenhouse gas monitoring equipment. But the site is very much the dendritic erosion, very small sort of peat pans and hags. We're talking maybe 20 centimetres sort of erosion around those pans. But then going into sort of gully beaches, and what we've got is a mixture of up in the top of catchment where we had the dendritic erosion, we had a very sort of complex arrangement of dip wells with continuous loggers monitoring water table depth every 15 minutes, which is a lot of data, particularly back when we were doing this work. And then we also looked at greenhouse gas fluxes in hollows, so small areas, rather than the flux tower work. And then we also looked at flow and water quality within the gully, sort of leaving that catchment area. And then to give a bit of a quick plug, we've just had a paper published that sort of will expand more on what I'm presenting today, so please go and check it out. We've made it its open access, and we've also published all of the data and methods associated with it, so please use it and get in touch. So obviously before restoration we monitored for 2 years. It was very much, as you can see in the photo on the left, dry, haggy mess. And they've come in and done the restoration work, and immediately we get these pools forming, which, so little conceptual model on the side there of, you had once upon a time very, very connected flow pathways, and then moved to these very much disconnected flow pathways, which unsurprisingly, it's me anyway, it's had a very sort of significant effect on flow within the catchment. So we sort of look at event-based analysis on all of that sort of flow and water table data. And what we found there was, I guess, from a natural flood management point of view, a bit concerning, but nothing important. But a slight reduction in the lag time. So in the lag time here, I mean from the peak rainfall to peak flow, that time decreased. But again, not surprising if you've got water being held in some of those pools, that that time will decrease a little bit. But promisingly, we saw about a 70% reduction in that rising limb of how quickly the flow accumulates. But also very excitingly, I guess, about a 50% reduction in peak flows and a reduction in the overall variability of flow within the catchment. So again, kind of a good thing. And for both smaller and bigger events, we also saw about a 60% reduction. So great. And then looking at water table depth, and just to explain what it is, I keep explaining to people not very well, so we've got so we've got in the pan, we've got a dip, we've got a series of dip wells, but what I talk about in the pan, we sort of have monitoring about 50 centimetres from the edge of the pan, so very much in the pool area post-restoration, and then we've got dip wells that are then 50 centimetres and then a metre and a half from the edge to try and get that sort of spatial effect of restoration. Promisingly, we found, well, not surprisingly, in wet conditions we saw a small increase in the amount of water that was held in those pools. But incredibly, because those pools have been created, we saw about a 3.5 centimetre increase of water being held in the pools, even in the driest and dry conditions, which again is just perfect for creating those conditions for change. And then, also in the surrounding areas. Again, wet conditions, slight increase in the water table, but again, promisingly a greater increase during those dry periods of time. And then, just to quickly jump into another site, this is a Hangington Hill site where we're able to set up a controlled restored care, so that is allowing us to, and we also collected before and after, so we've got a before and after control and intervention experimental design there. And that's just allowed us to remove the issues of different climates and hydrological years, but also get an understanding of how the whole system is responding to rainfall events. Promisingly, we had before and after, so the figure on the left. Both catchments behaved quite the same in terms of the flow there before restoration. If anything, there was slightly more discharge happening within the restored catchment. But following restoration, we've seen, I haven't done the stats on this, it's very much work in progress fast. But again, you can see it's quite clearly a significant reduction. So the blue is the the restored catchment, red being the controlled catchment. You can see a significant reduction in peak flows. Also promisingly, you can see that effect of what I was saying before about the pools filling up. And so for smaller rainfall events and at the start of the hydrological season, a lot of those events are totally buffered and you see very little water leaving the catchment. So it's that range is being actually held in peak, which is great. And then just very briefly looking at the benefits of having that before and after control and intervention catchment has meant that for us, our restored catchment was already wetter and slightly wetter than our controlled catchment. But because we've got before and after monitoring, we're able to see that actually, the overall variability in water table depth has decreased at the restored catchment, which again, excellent thing. And you can see, there's very clearly more water being held in the pools than there was before. Just very quickly on the right, that's sort of all of the flow data, and you can see that before restoration, more water was being discharged from the restored catchment. You can see it again, very clear, significant reduction in flow. And like I said, it's kind of not surprising when you see physical interventions in the landscape that, this is what's happening, but it's great being able to just properly articulate that with the data to back it up. And then, just going back to plateau pan, where we then looked at the changes in eco-hydrological function, so in terms of water quality and greenhouse gas emissions. And I think changes is probably a bit ambitious. We didn't see any significant changes in terms of water quality, particularly, so we looked at DOC, colour and metrics associated with that. And it's a bit surprising, but we didn't see any significant change in DOC concentration. If anything, it was a slight increase, but again, very much not significant. And more surprisingly, we didn't see a reduction in the total load of DOC that was being exported. So even though you're getting less flow through the catchment, those loads were still the same. So like a slight change in the way that the DOC was being exported, but we don't have quite enough data that I'd be comfortable to sort of talk about. But like the way that the DOC is sort of being exported during events has changed, but we're hoping to be able to answer that a bit more with a Hangington catchment where we've got continuous monitoring going on there. And then, in terms of greenhouse gas flux, don't ask me too much about it, it's mostly Naomi that's done that. But we didn't see any significant change in photosynthesis, respiration, or net ecosystem exchange. But again, not surprising given the changes we've seen in water table, a significant increase in methane fluxes. But again, I don't personally think it's a bad thing, so it's showing that we are improving or raising the water table, and we'll see what happens with time with that. And then, sort of reasons behind that is we were looking at up until 2018, so in the first 4 years post-restoration, and during that time we didn't see, particularly where we were monitoring, any significant changes in vegetation, but we have now, last year we were up there, or earlier this year, you can go and see, and there's a huge amount of sphagnum that's sort of colonised the area, a lot more aerial has come in, so this is where this next bit of work we're doing, starting to get into understanding that. But I think the key point here is that the restoration has created that foundation for change. And then, that sort of then just leads on to this trajectories of change work that we're doing. So where I said we've got a space for time experimental design, so we're working across 4 different sites. And also, for me, importantly, we're working at a pristine the Dartmoor site to get an understanding of what a realistic target is for particularly CO2 fluxes, because we don't really know what we're aiming for. And again, like we talked about in sessions earlier, the data collection just varies so much. So we wanted something that was consistent across all sites we're working on. And then, we've got flat top pan, which is now going to be about 10 years post-restoration, and hanging stone, which has got the control and restored, which is about 4 years post-restoration. And with that, we're monitoring CO2 fluxes, water table depth, flow, and water quality. And the way we sort of came about designing it was using geospatial data from 2010, so before any of the sites had been restored. And using what Richard sort of presented of that sort of structure as well as functional, in our case, like vegetation. So we've used LiDAR to come up with a whole host of different structure metrics, and then used red, green, blue, and coloured infrared imagery to then give that sort of vegetation metrics. To then come up with a classifier that works across all sites, so that we could come up with like-for-like conditions. And just to briefly demonstrate why, this is 2010 imagery, and then if you go to 2021, you can very clearly see the impact that restoration has had on the landscape. So we wanted to just make sure that we were starting with a similar baseline, so we know we could roughly say in 2010 structure and vegetation loosely was about the same in these areas. So then we've clustered all of that into 6 different habitat functional structural classes, which is roughly, again, it's quite hard to articulate, and I'm interested to read a bit more about how you describe it, of that sort of mixed blanket bog community where it's a bit flatter and you've got a lot more sphagnum in there, the bog cotton dominated, and then a transitional bit, and then linear dominated, and then there's horrendous linear toxic areas, and then the dry peat edges, and we're going to focus on the first 4 classes, so not doing the linear toxics and very dry gully edges, because there's a lot of reprofiling that's done on the gully edges, so we weren't happy to do like for like. But also within those, the areas that come up with linear toxics, I think just the timeline change in those areas is going to be well beyond the sort of 10 years we're currently operating in, and it sort of seemed a bit of a waste of time for now. I think it's maybe in a 15-year study we could do it. But that's very much just started. I think hopefully our tech's out today collecting some of that initial data, so we'll hopefully keep you posted on it. But that's it for me.
Hi everyone, I'm Jodie and I work in Northern Future Partnership in Peak District, National Park and South Carolina. And so I'm going to talk to you a little bit about our trajectories work, mostly on Kinder Scout, but also across the wider Peak District as well. This work is, disclaimer, is not done by me, so it's done by our science team. I work in the conservation work team, but I'm really familiar with the site, and so I'm going to tell you the general findings. Don't ask me any questions, please. I can sign those trees to the reports at the end as well. And we've been working very much in partnership. We're a partnership ourselves, and we've worked in partnership First of all, a bit of an introduction to our sites. This is an aerial picture of the summit of Kinder Scout, kind of quite an iconic place in the Peak District, and it's not a competition, but kind of a really, really degraded peatland. And so what Rich has just been saying about kind of first aid and recovery really resonated. And what you're looking at here is an aerial photo taken recently of quite a large part of the plateau. That's if you know Kinder. You can see Kinder downfall in the bottom right. And this kind of brown or black square rectangle is the bit that is our control plot, so it's the bit that we didn't do any work on. And there you can see a lot of black bare feet. You can see the white is actually down to mineral soil, so where that's our piece that has completely disappeared. You can see the kind of topography of really deep gullies, and in some places the gullies are almost kind of joined up together, so they're just kind of lumps and bumps, and some of those are really large, kind of 2 or 3 meters high. But then over here, we've kind of just noticed on Apple Maps, can you see that kind of pale green area? And that's one of our other sites. And so in a way, you've kind of got past, present and future, because the bit of pale green there is where we planted loads and loads of extra stagnant, and kind of press fast forward on the restoration process. And we've got 3 monitoring micro catchments, one on the Fairfield site, one where we've done a normal restoration, which is the red revegetation work, and the end catchment over there, the pale green bit, is where we've done fast forward and planted the loads of extra stagnant. I was chatting to my colleague Phil, who some of you may have met, who's here, and he actually helped do a lot of restoration work about, when did you say, told me to check. In 2010, he said he actually flagged out the control site. So this is how long we're going back now, 13 years ago. And he said they, on the whole of the Kinder Plateau, he reckons they spread 25,000 bags of heather brush. So it's been a very big effort to restore, or partially start to restore the site. So I'm going to mostly be talking about our results on this site, but and kind of similar to what Piers was thinking about, some of the different outcomes, but I've got a bit of a focus on hydrology as well. So first of all, talking about vegetation, and this is what we found across a variety of our sites in South Kent, but all very degraded sites that we restored. And so what you can see, when I say very degraded, I mean lots of bare heat. So you can see that the total bare heat cover at these sites has gone from almost 100% down to negligible. And total vegetation has gone much higher, fairly quickly, so you can see those, that's growth since treatment. Different types of vegetation that are taken. The blue line is the grasses. So at first you can have a really good growth of the nurse crop grasses, and then those are succeeded by the northern species of grasses that gradually drop again. The airways have gradually increased, and mosses, that's not particularly including sphagnum, but mosses have gradually increased as well. And just a little point on this graph is it's actually been really useful for us to have this long-term data, because the latest round, the Nature Climate Fund specified low seed burden heather for the brash that we use for our restoration, which is a real challenge for us to collect when the grant wasn't awarded till September, and we need brash kind of within the next few months. So with this data, we were able to say to Natural England, look, we've used we've used normal heather brash, not low seed burning heather brash, but the heather hasn't come to dominate. So we were able to kind of show that we can use heather brash that isn't particularly low seed burning and that it doesn't come to dominate and tails off. So that's been really useful for us in actually negotiating our funding based on the needs of what we can actually do. And we can't promise that to anyone else, but we can say that that's the case in our region. So that's been useful bit of data for us. This is one of the kind of, I suppose this is the best bit of data we've got in terms of telling the story. The sediment reduction from bare feet to once you either restored with extra sediment is that basically we're going from lots and lots of sediment to it's pretty much negligible. So the reduction in sediment is very fast and almost complete. And so the three different sites, F, the one with lots and lots of sediment, is the bare feet site. O is the restoration site, and N is the restoration site with extra stamping, which shows that there's a slight, with stamping, it's slightly better, slightly even better, if you like. Just check my notes, see if I've got anything. And so this now is kind of moving on to kind of seeing the difference and then measuring the difference between those sites. So on the left, again, is the bare feet site, looks like the rectangle of bare feet you can see. And on the right-hand side, we've got the restoration site with the extra stamping planted. So we can see that it's made a huge difference over 11 years, and it's kind of a completely different place, really. But we were looking at, we didn't even know if stamping would grow in such a critical site, so that's kind of the baseline that we were starting from. But we were, we have been taking measurements for all that time, and so we've got quite a nice long-term data set. And this is 5 years apart, so on the right we've got our sphagnum, and so we planted it very, very densely. So normally we would plant one plug per 8 square metres, and in this site we planted 8 plugs per 1 square metre. And so to answer one of the questions that was posed by this group was how long does it take to restore a peatland, and the answer is how much money do you have. So back of the kind of train ticket calculation that we did on the way down was that to plant 8 plugs per square metre it costs £60,000 per hectare. And that's just from the sphagnum. So, but in 5 years you do have this basically complete understory of sphagnum. So it's really, really growing well. It's really, really kind of covered the land, and there are amazing outcomes that we're seeing. So this is from the first slide I showed you with the pale green patch. That pale green is that sphagnum there, sitting in the bottoms, but sitting in the flow pathways, slightly less sphagnum on the tops there. So what did we find out? And that's just a close-up of that same area. So that's the Nogson site. graph. So what we've got, we have a big reduction in, so first of all, big reduction in their heat, which is the dark green line. And the indicator species are going up pretty fast, and the cover is also going up. And then the depth to water table is going up gradually, and the dotted lines are kind of projections into the future. We don't know what's going to happen, but if we project those lines upwards and extrapolate them, that's what we're expecting, that the water table will continue to rise, and so that's the purple line. Sediment reduces hugely, dissolved organic carbon, so just like Peter was saying, we're not seeing a change. And the stream flow I'll talk about in the next couple of slides. And sorry, that if you see there, after 5 years, that's when the extra spikes was planted, so that's that kind of extra change there in the indicator species. And the beginning of some of the trajectories going start to trend upwards after that initial rise. So this is just a quick one to show the sphagnum development, and that's in the different places. So in the flow pathways, you can see it just shot up, basically. It's kind of almost an exponential rise, and on the hill slopes, it increased, but not so much, and that's because of the availability of water. So in those curly bottoms, you've got a really, really thick blanket of sphagnum, and getting typical all the time as well. And what this shows us is that what we found is that, kind of a nice little infographic to show people and explain, is that on their feet, you've got a fast overland flow, no near surface moisture, the peat's not saturated, and the water table is low. When you've got revegetation, you manage to keep a little bit of the water at the surface. The water table rises a little bit. And then in the third catchment where you've got revegetation taking slowly looking and sphagnum, that sphagnum keeps more water at the surface. The water table rises more. And hopefully over time it will those gaps will close, and the water is slowed down much more by that surface of the sphagnum vegetation. So just a couple of graphs about the flow of water now. So each of the black graphs at the top are a single rainfall event. So they're not staying because there are 2 different rainfall events. The first one on the right is before restoration. So very similar to what Peter was saying. The peak discharge happened pretty much at the same time as the rainfall event. Each of the 3 sites were pretty much the same. Over here, there's different rainfall events. So on the F burning, again you've got the heat discharge happening as it rains really heavily, and there's no lag, very small lag time. The revegetated site, heat discharge is lower, quite significantly lower, and the lag time is increasing. And then on the northern, where revegetation, both looking and sphagnum plants, we can really see a huge change there. And I think we might have some numbers. So yeah, 67 percentage point reduction in heat discharge, and 880 percentage point increase in lag time. And the changes are continuing. So in those graphs there, we've got revegetation, and then when sphagnum is planted, you can see that those low price start going up, so lag times start increasing and continue to increase after the tracking plan decreases and continues to decrease. Which I think yeah, the biggest benefits are in the biggest storms. And you can read that through as well. But for people that aren't so kind of maybe versed in these ideas of peak discharge and lag time, the lag time is really important because the more you can slow a small chunk of water down into the catchment, and Kinder, this runs down into Glossop, which is a flooded, or has flooded, and it's a flood risk. So the slower you can make it at the top of the catchment, the longer you've got the bottom of the catchment for that water to find its way out. So you can have a really big effect on whether houses flood and whether towns flood and how much. And so, just bringing us on to the kind of what next, and this is one experiment on one hill, so we need to replicate it, but it sounds like we've got colleagues all over the country finding quite similar results. And yeah, so thank you very much for listening. Let me just check my notes, because I think I did try and answer. Yeah, I suppose, you know, a similar thing in terms of what next is this. It's the same thing. It's the long-term data sets and it's the continued funding. And sometimes as a partnership, we kind of have to grapple around and we kind of sneak out and take extra measurements where we can and try and keep those experiments running because we really need that long-term data. So, and like I said, hopefully no difficult questions. But I have done a QR code, and that will take you to our research page where all of this work is being written up. You can find out a lot more. So that's it.
Hi everyone, this is actually just a really quick one from me. I'm not doing a presentation, it's kind of an offer, if you like, from the National Trust. So I'm Tia Crouch, I'm the Central Peteropologist for the National Trust. And my line manager is Caroline Thorogood, who some of you might know. She's one of the senior national consultants for nature conservation. And she's not been able to be here today, so I've kind of come in her place to kind of give you this offer, if you like. Which one am I done? So earlier in the year, I think it was February, we ran a research workshop for National Trust and for existing academic partners. And nothing on this slide is likely to surprise you, but these were the agreed research priorities that came out of that workshop. So just to go through them, and some of us have been in a workshop about this morning, so looking at standard monitoring and data collection methods. This workshop, understanding restoration trajectories. A third one on sector-wide data framework and models, so that was more about having a kind of national database where everyone can feed data into so that there's data available for people to use. That also came up in the workshop earlier this morning. Decision making, so trade-offs, like so there are multiple benefits of peatland restoration, but what are the priorities? That's quite a useful thing for people to understand. And what works in terms of restoration techniques. So a lot of the techniques that we use, we've been using them for a long time, but there are some sort of more novel techniques that are coming along, so just understanding really what works. So, our offer really is, we're not in a position, the National Trust isn't in a position to maybe lead on any of those priorities, but we've got a lot of land, so our offer really is to connect up sites, practitioners, academic partners, and maybe help facilitate taking some of this work forward. So if that is of interest to anyone that's in the room, then please come and chat to me or email addresses are there, so you can get in touch with either myself or with Caroline after the conference. Yeah, and that's it really. Thank you.
Thanks, Tina, and thank you to all our speakers. We've got about 40 minutes now for discussion. I think we've just had a really great series of presentations there, bringing together some of the work that's going on out in the field. We've heard about a range of environmental responses, we've heard about carbon response, eco-hydrological response, biodiversity response, which Richard has reminded us about. And we've had some really good reminders to pay attention to structure and natural function, and really thinking about site recovery in a holistic and integrated way. And some pleas to be realistic about the timescales needed to evidence change and to achieve positive change. On the flip side, we've had a suggestion that funding might be the key to the pace of recovery that we're after. So some really great discussion points there, and Tia has just been telling us about how some of that work could be brought together for some thinking that the National Trust is doing, and certainly for the restoration roadmap for England's restoration ambition for peatlands. I think a lot of this chimes with our interest in really teasing out the difference between a delivery pipeline and what we expect recovery to look like over the longer term, just being clear what we mean when we say restoration. So I think a brilliant set of presentations that really set the scene for discussion. I'd like to invite all our speakers back to the stage. Thank you for the great presentations, and if you'd like to come up, we can take questions. Who has a question for our panel? At the front here in the blue, okay, that's fine. Go for it. And if you'd like to introduce yourself.
Thanks. My name is Andrew Gilroy from Regional Northern Groups. I just got a question here, and I may have misunderstood some of the slides. You're talking about the hydrological response to the restoration of it. And looking at the graphs, it appeared that if you looked at the confidence limits, they appear to overlap. And so how confident are you that the restoration, the hydrological response is an active response, as opposed to actually, is it not detectable and actually you need, another 5 or 10 years worth of study?
I'm fairly confident with it, to be honest. Like, I know there's obviously the confidence intervals around it, but if you look at the results we have from Painstone Hill, for example, like that's it's so good. Like, it's within, right next to it. Very confident that it's supposed to be discharge or restoration. And then after restoration, there is not a significant impact on deep flows and the buffering flows of water. And again, if you go up in I should be really mobile drone imagery, you can clearly see there's so much more water being held in the landscape. You can put like LiDAR bus sets, other aerial imagery bits, clearly see there's more water being held. I think like what's also interesting to me though is looking at where that changes down the line. Like how does the water table like stabilise more? I think that's maybe where the sort of questions are around. That's why I'm trying to get at that with the trajectory of change sort of project. I think in terms of that like immediate change, I think it's the disconnect in the hydrology up there is showing that. I think it's how does the water table then stabilise over time. That I think will come with more vegetation change as the structure sort of evens out, but more as the stagnant sort of reorganises the house.
Thank you. Next question.
Chris Miller, Natural England. Sorry, to get more from you. But also I'm going to bring in a little bit of Richard in there as well. I was interested about your DOC and also we saw from the future one as well that you were saying about DOC and saying no changes. Did you actually look at the composition of the DOC that was coming from the site? And did you see any changes?
Yeah, so that's a good one. So yeah, within that data set, yeah, we did see a change in the. I was getting very confused, but basically, everything we do see is leaving actually the darker material, so the more purified material. I think that comes down to the support for restoration. At the Homestead Hill site that we installed, we've got a multi-ground response installed there, and we're looking at the constant VOC concentrations there, and also doing some validation with that data. And there again, we do see that slight change in composition, but yeah, within the first 4 years, there's actually nothing significant changing. And that we had originally hoped that there was, because we're starting to see some changes in vegetation, but within that first 4 years, nothing significant. But I think, having the higher temporal resolution data we're starting to get now, we might see that. So if you've got dry periods and getting rain events through like that, we notice there is a bit of change. But this is work in progress for that one.
Yeah, and this is where bringing Richard's point, which is a very good one about timescales and time for the system to recover and to change. Because from my PhD, I found that changing vegetation type does change the composition, and it also changes how it responds to what's in the drying cycles and the microbial community that's actually broken down the peat. That also needs time to change. So I think we need to be careful when we're using DOC. I think it's a bit too coarse a measure, and we need to put that finer detail, but also we need to give it the time to do the changes. We're expecting the ecosystem to turn in 6 months, and it's not like that. It's not going to do that. So we need to give that time and space, and not get too hung up that we're not seeing an instant change, because we're asking a very big change of the ecosystem, because it's a dead store when it's there deep. To expect it to be, a few years later, look how fine, it's not going to happen, is it?
Yeah, no, exactly, and that's sort of the point we make in that paper. That's the point we make in the paper, is that we can't expect things to change in landscapes that be degraded over decades, if not centuries. I think that's just unrealistic. But I think again, for us, it's the way we're able to monitor these landscapes as well, because it is so variable. If you go up and collect water samples Tuesday versus Thursday in a week, you can get incredibly different DOC composition. So that is sort of where we're trying to really get a bit more of a better understanding of that very high resolution changes in temporal stuff. Was some of the data, previously we would have been a bit more confident with our results about it, but I just now knowing we can get higher resolution understanding it, I just get a bit more nervous about being confident about the results.
Do you have anything to add?
Me? Only just to repeat the point that time is a really important part of our toolkit, and we just don't use it. Well, we don't use it enough. But if it was a woodland, we would without thinking. So, we need to start applying the same timescales to what we do with peatlands as we would to a woodland. End of.
Hi, mine's a question for Richard. So Pamela Abbott from Natural Cambridgeshire, the local nature partnership here, but it's kind of a slightly another role I'm actually asking the question. So I really like your matrix of structure and your measure of softness. And certainly I go chasing grasshoppers across bogs, and I certainly notice the difference in structure and softness relating to what happens with the invertebrates. And I wondered if Natural England is thinking of incorporating that in their favourable status, or whether they do already, and I'm just not aware of it. It seems like a really interesting thing, and I just haven't come across it before.
There's fighting talk, given that I don't speak for Natural England. But what I can tell you is we've been using it with Natural Resources Wales for their New Life for Welsh Raised Bogs project. We've used the matrix, we've done some penetrometer softness readings, We're also using it in the greenhouse gas reduction project, as I mentioned. And we've just been, well, you saw the photo of us on Moorhouse. That was work that was supported by Natural England, and we've used both the matrix and the penetrometer on that site. So there is work being supported by Natural England that incorporates the use of that. And we actually had a training course with Natural England staff, and they were using the matrix and the penetrometer. They loved it. They mostly got excited about the little folding stool that I had with me. So maybe they weren't quite as focused on what I was hoping, but we've started doing training with that.
I'm sure that's not true, Richard. But I'll pass over to Ian. If you could, I know Ian will pick up on this, but just to kind of, as a general point, I know Natural England's work around nature recovery is really underpinned by the principles of natural function, and we've really worked hard to kind of embed that into the whole range of what we do on kind of supporting nature recovery. But I think Ian Dyack will have more to add.
Yeah, it's just Ian Dyack, National Wetland Specialist for Natural England. In reply to Pamela, we've got a big programme of protected sites monitoring reform going on at the moment. So a lot of this, we're considering how to change what's working, what isn't working. And certainly some of the assessments around wetlands and mires is going to be reviewed, and we will be adding stuff to that. So some elements of what Richard's talking about is very likely will be added, but it's not going to be immediate. Give us time
to convalesce. Any more questions? I'm just looking over that here. Just on.
Hi, Ian Detry from the EA. In a previous role, I attended the National Trust workshop that Tia Crouch mentioned in February, and I was part of a discussion around restoration trajectories. And there were sort of general questions about how do we know we are setting our sights on the right trajectory? What's the target endpoint? And is that going to be resilient in a world of climate change? And I wanted to invite the panel to discuss that.
Who would like to take that? Any thoughts?
I mean, like I said, like for us, I was quite keen to collect data alongside of what is like prestige Dartmoor, just to get an understanding of what we're even aiming for with these, because it's time, and it's so we just don't like. I would say we just don't know.
It's coming to me in a while.
So I think it depends on the landscape that you're looking at. So somewhere like the Peat District, where we've got so much degraded peat, bare peat, or had so much bare peat, loads and loads of work still to do. I think it's very easy to say what our targets are. It's to damage limitation, to stop the peatlands completely dying, or potentially even bring them back to life, which I'd say that in some cases that's easy, because it's kind of like, well, it's quite easy to do, and it's quite easy to make a big change. So I suppose that it depends on where you're talking about. So where we are, just making them not completely horrendous would be a good aim, I'd say.
While we're there, go on.
And that is sort of where we're coming from as well. You know, we have an indication of where our sites or where our peatland is. We have an idea of its condition. We have this target from the CCC. We're setting our own targets for the climate action plan, but none of them really mean anything until we have a better understanding of exactly where and what our peatland is and the sort of condition it's in. And what's really interesting as well is really understanding these significant climate events that are already occurring much faster than any of us anticipated and are already having significant impacts. So it's a tricky one to set a target, and then a particular drought event could have a significant impact on a restoration activity that you put a lot of work into, particularly if you're doing, say, experimental stuff, you know, or if then you've had a particularly wet kind of run of seasons and actually you didn't maybe necessarily need to do those works in that area. So it's a bit of a minefield, and I think she said just constantly gathering data, talking amongst your colleagues. Obviously I sit within the government agency, and it's just supporting our NGO network, making sure that whenever funds become available, we try to make them as long as we can. We fully appreciate that even the 5 years is really no good, and then the follow-up monitoring doesn't really seem to be ever included really in it, and that's obviously a challenge. So there's a lot in the mix there, so it's a great question, but I don't know that anybody has a hard and fast answer for it.
Thank you. Richard, did you?
If you want to be a doctor, you have to take the Hippocratic Oath, which is, firstly, do no harm. So all of our peatlands have harm. So the first thing is just mend that harm. That's what a doctor would do. Really a lot of what we need to do with our peatlands is just that. If we can identify all the various harms they're experiencing, and then we allow them to convalesce, they will decide what the end point is. I don't think we're in a position to say what a particular end point should be, because there are so many different factors that will influence that end point, not least the way the climate is changing things. So identify the harms, remove the harms, and let the system do its own thing. Although with the caveat that with FENS you then need to make a decision about what you want your end point to be.
Thank you, Richard. And while we're looking for our next question, I'll just add sort of on the restoration roadmap side, there's a lot in common between what National England partners are working on for the restoration roadmap and what National Trust have identified as research and evidence priorities. So we're working closely to make sure that they complement each other. But certainly one of the things that has come out of the work of the technical advisory group already is absolutely highlighting the need to think about the impacts of climate change, both on the deliverability of our ambition in terms of activity on the ground and on the expected response. So it's very much a kind of an area that we want to develop and advance on. There's a question. There's a couple of questions. Where have we got to?
One here first.
Great, thank you.
Thank you. Richard Guy, Forestry England. It's a quick question for Richard. Apologies, keep picking on you. And I realise this is ultimately going to be site specific, but where we are removing the harm that has already been done, if the process of removing that harm in and of itself could be considered as further harm, but will result in a better end result, is that, where do we strike that balance between doing further harm by removing past harm do you sort of see where I'm going with that?
Absolutely. Yeah. You've identified the doctor's dilemma. To what extent do they intervene? To what extent do they actually cause further harm in the knowledge that in the long term it will benefit the patient? And no, I can't give you a simple answer there, but that is, you need to think like a doctor. To what extent is my intervention ultimately going to achieve the objective of removing all trace of harm? It's a tricky one, I admit, but nature is complex and we have to try and work as best we can with that. Just keep the Hippocratic Oath in mind, all right? Thank you.
I was just going to add to that as well, that it's about putting resilience into the systems. At the moment, is that forestry system or whatever you're removing, is that a resilient long-term system? Or if you can create the foundations to start building a more resilient landscape, maybe that's a good thing. Thank you, Hannah.
Hello. Just build on that last point about do no harm, thinking about medicine and how some hundreds of years ago we had some tricky evolution in our medicine, body snatching and all the rest of it, but we now have heart transplants, we have brain surgery, we have skin grafts, all these sorts of things. Medicine has gone through that understanding of do no harm, but we've done some harm, but in a controlled way. We're now better than we are. Perhaps at the moment we're in that stage of peak restoration that medicine was in some 100 years ago, when there are so many unknowns. In order to do no harm, we do need to take a bit of a risk here and there, so we can get over that hurdle of having so many unknowns, peak plants being one example. Is that fair?
Hannah, is it fair?
Well, yes. In moderation, think like a doctor.
I'm not suggesting we go forward without control and carefully understanding. We start with monitoring and sharing information, but I think it's about, rather than trying to being scared of doing any harm, it's thinking about the bigger harm, and which may sometimes be to do nothing, maybe the biggest harm for it all.
Yeah, and also, I mean, we're doing less harm perhaps than we were doing in the past. So we've started on that journey, like we're no longer, mostly no longer putting in drainage ditches and casting peat. So we are on that journey.
Thank you. There's a question down here again. Chris?
Hi, I'm going to just push it back a little bit, if it's all right, on the do no harm, because we're looking at it through the lens of peatlands, and so we're saying about do no harm to the peatland habitat, but actually we are doing harm to biodiversity in that in some of the degraded habitats and some of the raised bog habitats that become degraded, they become home to other species which have been pushed out from other parts of the landscape. And so some of the last refuges are these sites. And so we do have these really difficult decisions to make about what to prioritise. So for example, I've had red pole and yellowhammer, red databook species on my site enjoying the birch trees on my raised bog. I've got a willow tit corridor running through. And so actually by doing the restoration, I've harmed those species. On the flip side, we went from 3 overwintering snipe to 150 on a little site. So we've also had some benefit. And I think we just need to kind of appreciate that in the decision making that we're making. We are going to have an impact. We are going to affect biodiversity in one way. And we need to have that at the forefront when we're making those decisions and be honest and open about it. I've knocked back the red pole and yellowhammer numbers in that area. I know I've done that, but I also know why I've done that, and I've also done the monitoring, and I can see the impact I've had on the other species that I wanted to bring back.
There is a bit of an aspect of making decisions, and we took out 125 acres of conifer woodland, which we had a nice root crop population in, but obviously they were having a predator radius effect, so by eliminating those 60 hectares, we brought in 400 hectares away from a predatory radii of ravens, crows, foxes. So there's lots of these decisions that have to be made. You have to go for the greater biodiversity good. I suppose we're struggling at times with, in Ireland the weather hasn't changed as much as it has in the east of England and east of Scotland. And yet we're getting these signs of it now, so it's a case of whether we act now when it's cheaper to make something resilient, or do we leave it later on. So that site I was chatting to you about earlier is sequestering 1.8 tonne in some. So but I know that it's going to get worse. Do we attack it now for £200 a hectare, or do we go off and attack something else and leave that?
thanks, Brian. And just a quick comment. I didn't want us to get too fixated on do no harm. What I was trying to emphasise was we should undo the identified harms. That's it.
Are there any more questions? If I may, Richard, I have a question. But it's not about harm. Just thinking about the long-term trajectory, you talked about the crisis that the patient might be going through in the recovery. Do we need more evidence about what that looks like for the trajectory of a pigment habitat, what we're expecting that turbulence to look like in the long-term upward, hopefully, direction? What do we need to do there?
Right, that is a really important question, because academics have never been under such pressure as they are now to publish. And so you get funding to do some work, you are under immediate pressure, especially places like Exeter, where they're really demanding publish now or die. And therefore, you're paid to go and look at some restoration work, and you must publish as soon as possible. So what you're publishing is the damage period, the crisis period. But you read the papers, you would never know that. The descriptions very often just say, this site was restored and this was the result. And that's a really dangerous thing. We need, as you've suggested, to be highlighting that what is being described as the crisis period, and it may look worse than you anticipate or want. But what we then need is somehow the work or the restoration site to be investigated longer term, so people can now describe, publish papers where they're actually talking about the true trajectory of recovery rather than this crisis period. It's a terrible problem with the academic publishing world and the academic world as a whole. We're just getting so many papers that are kind of instant gratification without really... Sorry, I don't need to crush your... So it's really important from the academic point of view that we describe exactly what it is we're publishing.
Hey, would you like to respond?
Yeah, in my defence. No, yeah, so exactly, I agree. So that paper we've just published, we've gone to great lengths to try and be look, actually we haven't shown positive change in terms of these sort of metrics, but what we have been able to say is set the foundations for it. And again, we're really lucky that we've had 10 years or over 10 years of collaboration with the South Speaking Partnership, and that we've been able to go back and, like with this paper, we sat on the data for a while because we did have some security. But yeah, absolutely, it's the problem. And it's also, I think, the way that stuff's funded, that a lot of it's like PhD students, and like PhD students have a very small remit and they have to publish in that time. So if you can start to do longer research projects, then that pressure comes off and you can really start to articulate it. But again, the only reason we could publish that paper and have the confidence in that story is because we're back there 5 years later and can sort of say that. But it's really hard to figure out how to go around that, and also how to communicate that in a way that everyone understands it, because there's a lot of worrying take-home messages that shouldn't be worrying.
Anyone else in the comments? Or any further questions? Right at the back, along my hands.
So we've been having some of these discussions about the last 30 years of left of harvest. We'll be discussing about how we can set some sort of restoration trajectory quite clearly for the uplands, the blanket bog restoration. because we know what that should look like. We know that we can make that look revegetated like on Kinderstown. But in the Fens, where I read that that's the biggest source of emissions in the UK, peatland emissions in the UK, what are our restoration trajectories for that sort of a habitat with the stakeholders involved, and how do we use the data that we have right now to make, what are our trajectories for the next 10 years of our 30 years left of harvest?
Who would like to come in? Anyone want to come back from the audience? I can certainly add something from the strategic end of things, but anyone want to add a Fen perspective? I'm not seeing anyone. So I would just add that the restoration roadmap flows from a commitment made in the England Peat Action Plan, and it very much focuses on habitat restoration, whereas the ambition around managing soil sustainably that are currently under agriculture, that kind of fits into the prevent degradation strand. And I guess where we'd be looking at where that would come into the scope of the roadmap specifically, and where we'd wanting to be articulating recovery a response trajectory, would be very much if you're moving away from that land use into habitat restoration. Whereas if we're looking at in the context of how many harvests are left and how we use that soil sustainably under the current land use, that's out of the scope of roadmap, but very much a really important question. So I think we have a challenge there, how to kind of knit those strands together and make sure that that's taken forward in the discussion. Any further questions? On the right here, Chris. There's two, sorry. Do you want to go first? Because Chris has already had one.
Sorry, I'm Betsy from Ridge Carbon Capture, and I think I just wanted to make sure that kind of I've got the message right in terms of what we're talking about, and I don't know, taking kind of Richard's example of the doctor, you know, when a patient comes in critical condition, the doctor doesn't wait to do any kind of intervention until they know that they have the perfect way of healing them, and they think it will take 10 years to find that perfect kind of method. And I think, as well, from our experience, there are a number of landowners and land managers who we speak to, and there's still a lot of reluctance to even start engaging on a kind of restoration journey. So I just want to make sure that we're still saying it's good to start now, and we need to get going with something, but maybe the compromise is we can't look at restoration as a one-off, and it needs to be something that needs to have kind of an annual element to it, rather than it being one thing and then for 30 years you can have your peatland continue to recover. So I think I just want to make sure that we still have the kind of urgency to at least get started, and then have it kind of a continuous improvement program beyond that.
Comments from that?
Well, yeah, that's why I use the example of the trauma room. You get in there as quickly as possible, and yeah, there is a danger that you know, scientists will always say, "Oh, well, we need to know a bit more," because we always do. But you know, reality, life is what happens while you're making your plans. Sometimes you just need to act, and we're in the middle of a climate emergency. We need to act. So that has to be the primary message. And we might not always get it right, but we can always adjust later, as long as we feed that adjustment system into whatever process we're employing. Absolutely.
I think it just also comes down to this expectation of what we want the final outcome to be. So there's commitments to restored by 2050, or on the road to recovery. Our peatland strategy, when it gets published, it's 2023 or 24. It'll be to 2040. It's a long strategy, reflecting that this takes a long period of time.
And the road to recovery has to reflect as well, or the outcome has to reflect, what is it for? Is it for carbon reduction? Is it for biodiversity? Is it for the flood alleviation? You know, what is the top priority there? And how we make these in very fragile environments resilient to our changing climate, so that they can help us mitigate against, but also adapt to. So yeah, it's a period of time, but absolutely we need to be engaging with our landowners. Absolutely, we need to get the message out there that this is really one of the easier ways of adapting to our changing climate, particularly with regards to the LULUCF sector. This is the one where there can be seen to be perhaps easier wins than, say, in some of the other sectors. So yeah, conversations still need to take place. We need field officers out on the ground. We need the funds in place. And we need all of that support, but at the same time always gathering the data and always reflecting back through our monitoring and evaluation programs. And if going on to this morning's conversation with regards to standardisation of data collection, we really need to be getting together as the 4 countries and really thinking about where do we want to go, and how do we all return and reflect on what we're putting in place, so that we are all moving and learning from each other in the interventions, or the scale of the interventions that we're doing.
Thanks, Emma. Did you want to say?
Yeah, you mentioned landowners, and probably 30 or 40 years ago I was involved in getting landowners to install drains in peatland. So the trust factor is massive. A lot of our upland peats, we probably drained them, to be honest, in the 1970s and 80s, and a wee bit early 90s. So it's a big U-turn. So it's very much a trust exercise. We have found out in the past, when we started agri-environment schemes in 1988, it was an exponential. It's a very slow beginning, and it's based on what you see your neighbour do and has it been successful. And I think that's why demonstration units are so important. Once a bog is healed, it's actually very difficult to show anything. So demonstration sites that show that you keep a few bad bits, that you're still working on a few bits, and that you have the end product are really important. And those demonstration sites have to be within accessible. They have to be dotted around the country, because everybody doesn't have the time to go on a 3-day conference.
Thank you. Anyone else want to? We've got a couple of minutes left. Okay, I think we have to draw it to a close there, but it's been a really great discussion. We've just got a couple of minutes before everyone else comes back in for plenary. So thanks everyone for a really engaged discussion. Just listening to all of that, there's just so much to think about in terms of our long-term ambition, and there's lots of very common threads that have come out, and I noticed some common threads certainly with the workshop this morning about uplands and lowlands, and the emphasis on language and being clear what we mean when we're talking about our ambition, and just being that the use of the word restoration, and whether we're talking about delivery action or recovery response, and I think that it makes a huge difference to the conversation, to be clear about that. So thanks everyone for a really great range of presentations. I think what we can take away is we need to be patient about the recovery of the patient. Thanks to our speakers.